Hello, I'm Anjali Sewani from NIT Kurukshetra Computer Engineering Department, and today we are going to explain DGIM algorithm. So DGIM algorithm is a data analytics algorithm, and it is Data Gionis India Motwani algorithm, and it is designed to find the number of ones in data set. So this algorithm uses order of log n bits to represent a window of n bit. It allows to estimate the number of ones in the window with an error no more than 50%. So how it will do that, we'll just go into depth now. So components of the DGIM algorithm. The first one is the timestamp and the second is buckets. So what the timestamp represents. So when each bit that arrives has a timestamp for the position at which it arrives. And if the first bit has a timestamp of, let's suppose, 1, so the second bit that comes after it will be a timestamp of 2 and so on. Now, rules for forming the buckets. So now what is a bucket? So here we are considering that we are keeping all the bits in a bucket. So the right side of the bucket should always store with 1, start with 1. So if it starts with a 0, so that 0 can also be neglected. So like we can see here that 1001011. So here from the right hand side, we are starting the bucket from 1. And this bucket will be considered a size of 4. So now here bits are more than 4, but why we are considering it as a size of 4? Because the number of ones in this bucket is 4. So basically, the bucket size will be of the number of ones present in that bucket. And the buckets that we are forming should be in the power of 2, should be in the order of the power of 2. So let's suppose in this example, the bucket size is of 4, that is 2 to the power 2. Now, the next bucket can be, the next bucket, if we take example, our next bucket can look like this, 1001. So here the bucket size is of 2. Now the bucket cannot decrease in size as we move from to the left, like from right to left. So what does that represent? We'll see. Now, let's suppose we have an example like this. So we cannot have a bucket like here, it is of size 2, then a bucket of size 1. We cannot make buckets like this. So if we want, the bucket should be like in this example 1 and 1. Let's suppose this is a bucket of size 1, this is a bucket of size 1. Then we have a bucket of size 2. Here, as two ones are present. Then we have a bucket of size 4. And the most important thing being that if we are forming the buckets, two buckets cannot be of the size more. Let's suppose we have a bucket of size 4, then we can have only two buckets like this. Now we'll see through example that when in a data stream, a data comes, then how we'll update the buckets, how we are going to form the buckets. So initially, this is the number of bits that we have that are present with us. So initially, n is equals to 24. It means the window size is 24. We are dealing with the 24 bits for now. So now after this, when we have to form the buckets, as we can see, initially we are forming it as bucket of size 1, then two buckets of size 2, then two buckets of size 4. So now when a bit enters, which has a value 0. Now when it comes, so we can just ignore it as we have defined that the bucket from the right hand side should start with only 1. So we can neglect this. Now when 1 enters, so we have to update the buckets. So now we'll form it as a bucket of size 1, a bucket of size 1, then 2, 2. Here, there will be no change in the upcoming like buckets. Why we are doing so? Because as we have already discussed, that we can make buckets two of same size. Now, when the next one enters, so what happens here that we cannot just simply one make like this, like three buckets of size 1. So we have to make some modifications. So now one enter, so it will form a bucket of size 1. Then we'll merge these two buckets. It will form a bucket of size 2 and so forth. So now what we'll do when we have to answer the query, that how many ones are there in the last 20 bits. So if we see through this, so what we are finding is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So till here we have to find. So till here we have to find, and we have in total of, if you can see, in total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total we have 11 number of 1 bits. So how we'll calculate it? We can see that in according to timestamp, we'll check that in these buckets, how many ones are present, because the bucket size itself represents that how many ones are present in that bucket. So here we have 4 ones, we have 2 ones, and we have 1 1. But the interesting thing comes up when we are dealing with the last bucket. So what we do in the last bucket, we have to consider half the size of the bucket. So here the bucket size is 8. So we'll consider it as 8 by 2. So our answer will be the sum of these. So 4 plus 4 plus 2 plus 1. So this is going to be our answer. So thank you so much.
So now we'll look at the code. The code is written in Python. So at first, what we'll do is we'll create an input stream. You can just create a text file in which we are providing the stream to 1 space 0 space 1, which is basically a binary stream, right? Since we are counting the number of ones here. So at first, we'll just open this file, which I have saved like this, and then we'll read those lines, and then we'll close this file. So after that, what we'll do is we are creating this area of stream, and then so what we are basically doing is in next lines, as you can see from this to this line, what we are doing is we are providing those uh, binary elements into the stream as integer elements. So it will just create, it is just creating the list of all the integer elements as 0, 1 in form of stream. So then we are just printing the length of stream, the number of zeros and ones in stream, right? Here we have considered the window size equals to 1000. So then we are creating this layer. Layer basically means over here we are just creating an array of array here. Since you can see, we are creating arrays for I in range 10. Why we have used this 10? We have used this 10 according to the calculation of log 2 of window size plus 1. Then we are getting this 10. If we have to update, this function is for updating the buckets, right? This function is for that. We'll come to it. So, but at first, what is happening is start time, we have taken this for I in range length stream, which is basically the timestamp. Since every element in the stream has some timestamp, which is 1, 2, 3, 4, 5, 6, and goes on like that. So if stream element I is equals to 0, we don't care about it. But if it's 1, which is of our importance, right? So we'll update the buckets as you saw in the explanation only. I'll explain it the update function. But at first we'll just count, we'll just focus on counting, right? Count of time window, the window which we have provided, obviously. Here we have provided the window size as 1000. So initially we have taken the count equals to 0. Count basically here represents the number of ones, which would be our answer only. And num equals to 0. Num basically iterate through those 10 I explained earlier, right? These array of 10, these 10 arrays basically. So flag equals to true. So while there is something in that layer num, right? At index num, if that array has something, if it is not empty, then and flag is true, then we'll go into this loop. Here we are providing this array, layer num is an array. So we are assigning it to list. So now we are iterating through this list only. So for j in list, if it is lying in the our window right now, so in that case, what we'll do is we'll consider it in the window and we'll calculate the number of ones in this. So in this case, what we are doing is we'll be providing the bucket size, which is a equals to method power 2 to the power num. Num, this one. It can go up to 10, right? So sorry, 9. So from 0 to 9, it can go up to that. So then we are just increasing the number of ones. Count plus equals to a. Since we know bucket size represents the number of ones. If that's not the case, if it is not lying in the window, then we'll just put flag equals to false. Similarly, we'll just update num as the bucket size is increases. We know that. So after that, for the final bucket, we have to count the number of ones. So what we will do is we'll provide just count minus equals to a by 2. A was the size of the previous window. So last window, this one was the last window and a was the size of it. So we'll just subtract minus a by 2. Since we consider in the last window, there are number of elements are number of ones, sorry. So then we'll return this count only. So this is how we are getting our answer, right? The number of ones in a string. I'll just quickly explain this update function as well. Since we know as soon as we encounter any one is entering into the string, we have to update the buckets, right? So for that case, we have written this update function. So in this, what it will doing is, it first of all will providing the timestamp. So the layer 0, which is an array, obviously, will just list, in that list will append this timestamp, right? So, and then we'll just iterate through it. So for all the i's, like from 0 to 9, obviously. So for these, while length of layer I is greater than equals to 3. What it means is, if this layer I list is containing more than 2 elements, then we'll go into this loop. So here, if it is lying if layer I0 is greater than equals to timestamp minus window size, right? So in that case, what we'll do is we'll just append layer of I1 into layer I plus 1 and just update layer I from layer I to this from updated to the second element of layer I and thereon, right? Else, what we'll do is we'll just update layer I only and we'll update it from its original to the it will be going from first index to the rest of it. And we'll be updating I as you can see over here. So this is it from the code side. I hope you understood it and everything was explained in the explanation. So you may write the code yourself as per your convenience. So thank you so much.